Okay, Boxplot in Excel, we've got two options. One is the worksheet that I provide, and the other is Excel allows you to do it. However, I find it looks best if you have your data in two columns. So here we have gender and here we have weight, but I'm not pleased with how the Boxplot looks. So I've sorted the data, put them in their own columns. Then you go to Insert, click here, go to All Charts, Box and Whisker, hit OK. Also, it doesn't give us any labels, so you can go up here, kind of play around with the chart, and get the one that gives us the labels. So you can visually see there's a difference between men and women when it comes to weight, which is the point of the box plot. The line in the middle is the median. If you have a little dot up here, that's an outlier. And then remember, this is your data placed in quartiles. So first quartile, second, third, fourth quartile. Now the other option is to go to the Excel spreadsheet I gave you, which gives you more information. So remember, in column C26, you change your labels. I'm going to change this back to sample 3. It'll auto-populate those labels down here. Delete the data, and now I can come and bring the data over. So let me first get female weights, right? And we're assuming they are different. We just want to visually confirm our hypothesis. So there's female. And now let me go get male. Notice that the columns are different lengths, so we surveyed or weighed more men than we did women. That doesn't matter for the box plot. And we paste male here. And we scroll back up, and yes, as we assume, the median weight for men is much higher than the median weight for women, and then we can see that here. The median for men is 155. The median for women is 122. We also still see that outlier, which is 215 pounds. So I don't know what country this is. It's definitely not the USA, but someone that weighed 215 pounds was an outlier. Could be adolescence, and maybe that is why the data looks the way it does. But again, the box plot just is a visual understanding of, do we have a different median? And do we have different variation? So I would argue we do not have different variation, meaning their standard deviations are probably fairly close. So while the medians are different, the variation is not.